Welcome students. In this class, during previous class, we have discussed about scalar and vector quantities. What kind of the quantities are called scalar quantities, how the scalar quantities are represented, and what kind of the quantities or the types of the quantities vector quantities are, how the vector quantities are represented graphically or otherwise. So we have discussed in our previous class. Now in this class, we are going to discuss terms associated with motion. What are the terms? Number one, position. So terms associated with motion. This will be our fourth lesson for this chapter. So what are the terms which are associated with motion? Number one, position. Number two, distance and displacement. Number three, speed and velocity. Number four, acceleration. These are the basic foundations to understand so many physical quantities. So you have to focus, you have to concentrate, you have to understand what the position of anybody, how the position of anybody is represented, what's distance, how the distance is represented, what's the distance and displacement, how the displacement of any body is represented. Then we will move up to speed, define speed, we will find out the mathematical formula, we will move up to the unit of these quantities. Like distance, we will define distance, we will go up to the formula of the distance to calculate distance, then we will see what's the nature of this distance, is either it's scalar or it's vector quantity. These are the main steps to understand these physical quantities. Similar will be the case with the acceleration. So we will complete in two consecutive classes for these topics. So what's the position? Position is, it describes the location of a place or a point with respect to some reference point. The reference point is called origin. If you draw a line along x and y axis, and you will see that from these two axes perpendicularly points at a point that is called origin, which you have already seen when you were representing, graphically representing the physical quantities. You have seen how the position of origin is taken. It is between x and y axis. It starts from the point where they are meeting at a single point. So moving for the next, this is the concept of distance, the total length of a path between 2 points. So we are not concerned with the straight path or anything else. We are, a cyclist is following this path, he's moving on this road, covering a long distance and reaches up to the other point. So this is the length of the path. He is following this path and we are only concerned with the length of path. We are not concerned with the direction from this house up to the destination of the factory. If you see, it's 120 meter, but if he is moving along this road, he is following 200 meter. So is this 200 meter without any direction is basically distance. But if he moves from directly from house to the factory, it will be a different quantity we will discuss during the next slide. So it's a scalar quantity. This is the nature. What's the unit? Unit of distance is meter. How it is represented? It is represented by s. So these are main steps which you, if you follow, you will clearly understand what the distance is. Scalar quantity, unit is meter. It's the total length between the two paths, and it's represented by s. There is c, there is no arrow over s. So next is displacement. And this is basically, displacement is defined as, it is the shortest distance between the 2 points. It has both magnitude and direction. If you see in the last, if you go from this house directly to the factory, this is the shortest distance. It's 120 meter, but in case, the other case is 200 meter, this is distance. This one will be displacement, which is the least distance between the 2 points. So come back. So it is represented by D. If a rat is moving along this path, moves and goes up to a circular path, reaches up to this piece of pad, then this rat is following a distance. But if this rat directly goes from this position up to the directly towards the piece of bread, it is the least distance called, and it is a vector quantity. How it is represented? It is represented by D, and it is a vector quantity because direction is there. Its unit is also meter. So this was displacement. Now, what are the examples? Consider the figure in a curved path, this one, and let's S be the length of the curved path between A and B. This S is basically this one, moving along this and reaching up to the B. This S is basically distance. But if you are moving from A and following this path straight, this one is the displacement. Look, then S is distance between A and B. But if you join A and B via a straight line, you are joining A and B with a straight line. This one, straight line, this is a displacement. This is the shortest distance between the 2 points. Now, what is speed? Speed is defined as the distance, first of all, definition, then we will go mathematical form, and then we will see what's the unit of this speed. Nature and unit. Definition is the distance covered by an object in unit time. If a body is covering distance, you are saying on phone, I'm moving with this and this, covering so and so distance. So it clearly shows that you are not moving in any direction. So if you are having any direction, then it's not a speed. So if you're covering a distance per unit time, that is called basically speed. If a body covers distance s in a unit time t, then speed is, how will you calculate speed? Speed is calculated by distance covered per unit time. So formula is this one, v represents the speed, s represents the distance which we have already discussed in the last class, t represents the time. So how will you calculate distance then? Distance is calculated by using normal mathematical techniques are the formula, that is s is equal to vt. Means if distance here you are writing s, here s will be at its own place, t you divide both, multiply with the t on both sides, you will be getting s is equal to vt. This is the formula to calculate distance. It means when you are defining speed, anyone tells you this is the speed of any object, and it is covering, it is after certain time, 2 3 4 hour minute second, calculate the distance covered, then this will be the formula to calculate the distance covered by the body. S is equal to vt. S is equal to vt, speed given time, after certain time you are asked to calculate distance, you will use this formula to calculate. But in case if you are asked to calculate the speed of any object, you will be told that the object is covering such a such distance in during such interval of time, what will be its speed? Then you will calculate speed v. So this is the formula to calculate speed of any object. When distance is covered in a certain time, you will calculate the distance. So if you are asked to calculate the distance, then you will be told that the speed of the object is so and so, after this time calculate the distance covered. So you will use this formula, s is equal to vt, to calculate the distance moved. Now what's the nature of this quantity speed? Its nature is scalar quantity because it's not having any type of the direction. Now the number two, its unit, the unit of speed is meter per second. You use, if you look at the back side, this is the s is equal to v is equal to s over d. Unit of distance is meter divided by time, second. So the unit of this speed by looking at formula will be meter per second. So same is here, meter per second. So what are the kinds of speed? Instantaneous speed, variable speed, average speed, and uniform speed. These are the four different types of the speeds which we will discuss. Now, instantaneous speed, instant means smallest interval of time, very small interval of time, which is uh, closer to zero. That is the unit of the body, the speed of the body at a certain instant interval of time. That is del s over del t. Del t is basically time interval. More is the smaller time, more will be the instant to calculate the speed. What is the variable speed? The units of the whatever the types of the speed is, all these points are common. Other than the other than the definition, formula will be same, unit will be same, nature will be same. So these are the different. Uh, where is the difference? Difference is in case of the definition instead of time. Variable, when a body does not cover equal distance in equal interval of time, or however short interval may be, whatsoever the short interval may be, if the body is not covering equal distance in equal interval of time, then its speed is said to be variable. If you have a road and you mark equal distance 5 meter, 10 meter, 10 meter, after 10 meter, each the gaps are having, each time the gap is 10 meter. And if you see the first 10 meter, the car is covering in 2 seconds, first 10 meter is covering in 4 seconds, and then it covers 6 in 6 seconds or 8 seconds. So the equal distance is not covered in equal interval of time. This is the example of variable speed. So what about the average speed? Average speed is total distance covered divided by the total time. If you divide the total distance covered on the total time, this is the sign of average, and you are calculating total distance divided by total time. So you will be calculating the average speed of any object. And what about uniform speed? Is the most simplest one. If a body is covering, like I have given you example for the variable speed, if you mark 10 meter distance, equal distance on the road, and if you see the first 10 meter distance is covered by a car in 2 seconds, then of course during second portion or the second block, it must have covered the same distance in equal, that is 2 seconds. And for the third portion, if the car is covering with the same distance in same time, then this type of the speed is called uniform speed. So let's have some quiz, and you have to find out the answer. Which is the fastest animal on earth? Leopard, cheetah, or gun? So here is the answer. Falcon can fly at a speed of 200 kilometer per hour. What is the speed of cheetah? 70 kilometer per hour. And it's a light detection and ranging speed gun. It uses the time taken by the laser pulse to make a series of measurements of a vehicle, distance from a gun, a motorway, speed camera. Type of the techniques of the camera used to calculate the speed limit of the cars on the road. Most of the time, you people have seen that traffic people are along the road. They are trying to judge or calculate the speed of the cars moving. So a body is moving with uniform speed. Will its velocity be uniform? If a body is moving with uniform speed, may have uniform or variable velocity. If the direction of the body is not changing, velocity is uniform. Otherwise, variable velocity. Example. A body moving with uniform speed in a straight line will have uniform velocity. If direction changes, then the velocity is variable. Example 2. A body moving with uniform speed in a circular path will have variable velocity as direction changes at every point on the circle. These were two examples to understand how the velocity is variable and how the speed is uniform. So our next topic is for velocity. Same sequence we will follow. The difference between velocity and speed is the distance. Where there was distance, here it is displacement. Distance covered per unit time, that is speed. The displacement covered per unit time, that is velocity. Where direction comes, you will define it in velocity. The displacement covered by a body in a unit time. Rest, formula, everything, you will see that the almost it is same, but you will place arrows to represent the vector quantity. What's the symbol? It is represented by V, and over arrow. Arrow shows it's a vector quantity because it's displacement covered per unit time. This is the main difference between speed and velocity. What's the mathematical form? Mathematical form is that average speed is equal to displacement covered per unit time. How will you represent displacement? D over arrow. This is the vector quantity, and T time displacement covered per unit time. Then what will be the unit? Before we go to the next slide, let's see here. The unit of displacement is also meter, and similarly the unit of time is second, so its unit will be meter per second. So or if you are given displacement, you are given time, displacement covered per unit time, you can calculate the velocity of that body. But if someone tells you that the body is moving with such and such velocity, after certain time, 2 minutes, 2 hours, 2 seconds, after certain time, calculate the displacement covered by the body, you will put the value of given velocity through which the object is moving. You will multiply the time required after certain how much time, then you will be getting the displacement. You will get the displacement covered by the body. So these are the nature. What's the nature? Nature is it's a vector quantity. It has direction as the direction of the displacement. Whatsoever the direction of displacement is arrow, this will be the same direction of the object. So that's why it is the vector quantity. What's the unit? I have already discussed. Units are the same with the unit of the speed was. Its unit is also meter per second. What's the example? A body moving in a straight line. Kinds of velocity. These are five kinds of velocity: instantaneous velocity, variable velocity, average velocity, uniform velocity, and relative velocity. These are 5 types of velocities which we will discuss during our next class. I hope you people have understood. I thank you all.